All right, if you're a senior architect juggling a multi-cloud setup, you know the deal. Everyone expects you to have the answers, like right now. But the problem is, those answers are usually buried under an absolute avalanche of data. So today, we're going to give you a framework to cut through all that noise and find the critical signal. So let's just start with a really important question. I mean, you're collecting terabytes, maybe petabytes of log data, but when something actually breaks, can you find what you need? Or are your logs just creating more problems than they solve, hiding the truth in this massive sea of noise?
And that right there, that's the heart of the problem. I call it the log data tsunami. You know, in this cloud-native world, we got obsessed with this idea of collect everything. But the thing nobody talks about is that more data often leads to less insight, not more.
Now get this number it's honestly a little staggering. Industry analysis shows that something like 85% of the log data most companies collect is just low-value noise. Just think about that for a second. You're paying to ingest it, you're paying to store it, but it's almost never even looked at for actual troubleshooting.
And what happens when you hoard all this noisy data? Well, it's a double whammy for the business. First, your observability bills just go through the roof. And second, when something really does go wrong, your teams are slowed way down, having to dig through mountains of irrelevant junk just to find the root cause. It's expensive and it's super inefficient.
So what do we do about it? How do we fix this? Well, we have to change how we think about this whole thing. The goal isn't just to collect less data. No way. The goal is to collect smarter data. And that is where we begin our search for the signal, through what we call intelligent sampling.
And that leads us right to this core concept, precision signal. Don't think of this as losing data. Think of it more like you're tuning an old-school radio. You're carefully turning the dial to get rid of the static so the music comes through crystal clear. It's all about strategically cutting down the volume to make the really critical stuff, the errors, the key events, stand out. You're amplifying what actually matters.
Okay, so let's start with the basics. The two most common ways to do sampling are called head sampling and tail sampling. They're really just two different philosophies about when you should make that call to either keep a log or, just drop it.
And right here, you can see the fundamental trade-off. Head sampling is all about speed and low cost. It makes a decision right at the very beginning of a trace, the full journey a request takes through your system. But tail sampling, well, it's smarter. It waits. It waits for that entire transaction to finish so it has the full context. Did it end in an error? Was it super slow? It knows the whole story. But all that context comes at a price. It's going to use more memory and more processing power.
The best way to think about this is with a simple analogy. Head sampling is kind of like deciding if a book is good just by reading the first page. You might get lucky, but you could totally miss a masterpiece. Tail sampling, on the other hand, reads the entire book before it writes a review. It's always going to be more accurate.
Okay, so knowing whether to read the first page or the whole book is a great start, but it's really just the beginning. Let's level up and look at some more intelligent strategies that give you almost surgical precision over what log data you keep.
First up, we have error-only sampling. And let me tell you, this is a massive win for any engineering team. The logic is so simple but so powerful. If a transaction fails, if it throws an error or an exception, you keep 100% of the logs for it, no questions asked. For everything that works just fine, you can sample that stuff way more aggressively. Right away, you're shining a spotlight directly on the problems you actually need to solve.
Next, we've got metric-keyed sampling. Now, this one is really, really cool. Imagine you want to make sure you're seeing logs from all your customers, right? Not just the big ones that send a ton of traffic. Well, you can key your sampling on an attribute like customer ID. This makes sure that even your smallest customers get a representative sample of logs, which gives you a much more balanced view across your entire user base.
So how does that actually work in practice? It's pretty straightforward, really just a three-step process. First, you pick that key metric, like user ID or maybe an API endpoint. Second, you just set the rules for the sampling rate based on that key. And third, the system just takes it from there, automatically and consistently applying that rate so you get that balanced, representative view you're looking for.
Okay, the theory is great. I get it. But as a multi-cloud architect, you live in the real world, right? So the question is, how do you actually do this stuff across AWS, Azure, and Google Cloud? Let's pull up the blueprint.
All right, think of this table as your practical cheat sheet. As you can see pretty clearly, the basic stuff, head sampling, that's usually supported right out of the box with things like ingestion or exclusion filters. But look what happens as you get more advanced. For tail sampling, all three of the big clouds are going to require a third-party collector. For error sampling, you can sometimes build custom logic like with KQL, that's Kusto Query Language, in Azure, but it starts to get tricky. And for metric keyed sampling, yeah, you're almost always going to need a third-party agent. The big takeaway here is that the native tools are fine for the basics, but for the high-value strategies we've been talking about, you'll probably need to bring in some specialized tools.
But here is the most important point of all. Don't get bogged down in the specific tool or the exact implementation on each cloud. The tools are going to be different, and they're going to change over time. What really matters is that you understand the strategy, the principles of head, tail, error, and metric keyed sampling. That knowledge, that's something you can take with you, no matter what your stack looks like tomorrow. And this quote, man, this just says it all. This isn't about being cheap. It's not about just throwing data away. It's about curation. The goal is not to lose data. The goal is to gain clarity.
All right, so let's wrap this up. What are the big things you need to remember? First, sampling isn't just about saving money. It's about making your important data easier to find. It's a signal enhancement strategy. Second, start simple. Get some quick wins with basic head and tail sampling. Third, from there, evolve to the more intelligent strategies like error and metric keyed sampling to get real precision. And finally, always adapt your strategy to what each cloud platform can actually do.
So I'll leave you with this final thought. For way too long, most of us have just been drowning in data noise. Now that you have a real framework to strategically cut through it, the real question is, what critical signals about your systems, your performance, and your customers are you finally going to uncover?